do any further reading, make sure that it's acylation and not alkylation, because there are two well-known Friedel-Crafts reactions. There's acylation and alkylation. And we're not doing the alkylation. Now, for this, we're going to acylate it. We're going to add an acyl group. An acyl group is basically that. So it's a CO double bond and some sort of R group. That is an acyl group. So we're going to add that onto it. So we're going to generally react it. We're going to react it with an acyl chloride. That's the actual chemical. Now those two together, this is not a powerful enough electrophile to react with benzene. So we're going to add as a catalyst aluminium trichloride. And that is going to acylate benzene. So we've added our acyl group onto benzene. So this is a Friedel-Crafts acylation. So just like with the nitration, there's a pre-reaction that takes place to form the actual electrophile that is powerful enough to react with benzene. So that pre-reaction takes place between the aluminium trichloride and our acyl chloride. Now the way you can think about it is that the aluminium trichloride just rips the chloride off of the acyl chloride. So it's going to rip a Cl- off of this, which is going to form AlCl4-. And this thing. So we've got a C positive. So a carbocation bonded to an electronegative atom. This is insanely reactive. So this is very, very, very highly reactive. And this is what's going to react with the benzene. So we're going to take this and the mechanism now is identical to what nitration is, just with a different electrophile. So we're going to take the electrons from the ring, not one of the bonds, from the ring, and donate it to the positive there. That forms a bond between one of the carbons and the carbon that did have a positive charge. But we still have our H there. We then look at the carbons either side of the one we attached our electrophile to, and we drew a horseshoe that starts behind but doesn't go past those two there. We then put the positive charge on. And then in the second step, we break the CH bond and we put the electrons into the ring, reforming our aromatic ring. And also producing H+. So that's the end of the mechanism. What you will almost always then be asked to do is to show how aluminium chloride acts as a catalyst in this reaction. Because so far it's not acting as a catalyst. If you just took the information we have here, it is not acted as a catalyst. Catalysts speed up reactions, but are not used up. And so far it's all been used up. We've formed a load of AlCl4-. So for it to act as a catalyst, we need to regenerate it in this reaction. So you're going to need to write an equation to show that it's been regenerated. So at the end of this, you're just going to need to add AlCl4-, and that's going to react with this H+ that's been produced in this final step. Those react with each other to form AlCl3 and a molecule of hydrogen chloride, or HCl. And so we have regenerated our catalyst. So you don't need to write any, you don't need to explain anything in words. You just need to add this onto the end of your, the end of your reaction. So this is what it's like a 5-mark question. If you're asked to show the reaction between ethanoyl chloride and benzene to form the BSCH3 there, we'll look at how we name those because it's a bit complicated. But how to form with a CH3 there. You would draw this out like so, and then part of the question will be to explain or to show that AlCl3 acts as a catalyst in the reaction. You just add on this one line down the bottom. binding AlCl3. So that is certainly all of the aromatic chemistry we're going to be doing for this lesson. That's quite a lot, and it is not an easy mechanism. So I'm going to give you some questions to practice looking at the bonding in benzene and the electrophilic addition reactions. So have a good go at those. Do some reading around. There's loads and loads of resources available to help you. And I look forward to seeing your answers, and I'll give them a check through and mark those.